Hi everyone, welcome to PRAKASAM tutorials. In this video, I am going to design collinear array antenna design using HFSS software. In collinear array antenna elements are simply arranged in a single line. So these are the antenna elements. Antenna elements are arranged in a single line from one end to other, which means that one after the other. So this arrangement can be either horizontal orientation or vertical orientation. And this is the horizontal orientation of the collinear array antenna, and this is the vertical orientation of the collinear array antenna. So similar to a broadside array, this collinear array antenna provides radiation in the normal direction to the antenna array axis. The direction of the radiation pattern in broadside array antenna is perpendicular to the axis of the antenna array. So similarly, the collinear array antenna, the direction of the radiation pattern is normal to the antenna array axis. So this is the antenna array axis. So now open HFSS software. In my previous video, I already designed vertical dipole antenna. This is the vertical dipole antenna. So first to design vertical half wave dipole antenna, and this is the design of the vertical half wave dipole antenna at 2.4 GHz operating frequency. So now where the elements are arranged in a single line in a vertical manner. So now select all the elements. Right click on the element, go to edit, select duplicate along the line, duplicate along the line. So click in center position, little bit drag, select the number of elements. Now here I am selecting the number of elements are 4. Click OK button. And distance between the elements is lambda by 2. So now here the operating frequency is 2.4 GHz, the wavelength is 125 mm, and lambda by 2 is 62.5 mm, and the distance between the elements is 62.5 mm. Now here vector position is 0, 0, 62.5 mm. Now click OK button. It all the elements are shifted in a single line 62.5 mm. And second dipole element, lower radiating element, here also, and vector position is 0, 0, 62.5 mm. Click OK button and select fit all. Next set the port. Now here the vector position is port vector position is 0, 0, 62.5 mm. And this is vertical collinear array antenna design. Now select the radiation box. Now here I am selecting open region radiation box, and this is the design of the vertical collinear array antenna. Now check the design validation and now start the simulation. Completed. Now check the S parameter value. This is the S parameter curve. So at 2.4 GHz operating frequency, the S parameter or the return loss value is minus 23.48 decibel. So now let's check the radiation pattern, 2D radiation pattern and 3D radiation pattern of vertical collinear array antenna. And first observe the 2D radiation pattern. So now the selected elevation geometry. So the elevation geometry is pi value is 0, 90 degrees. Now select the gain without decibel, click new report. So now here all the elements are fed with current with equal magnitude and same phase shift. So now go to the field overlays, edit the sources. Now the magnitudes are first element magnitude is 1. Now all the elements are fed with equal magnitude. So now edit the magnitudes. All are having same magnitude and same phase shift. So now click OK button. And this is the 2D radiation pattern of vertical collinear array antenna. And with decibel, and this is the 2D radiation pattern with decibel, and previous one is without decibel. And next observe 3D radiation pattern, 3D polar plot. So without decibel, the gain is, this is the gain radiation pattern. Without decibel, the gain value is 4.5, and with decibel, the gain is 6.53. Next, observe the radiation pattern with structure. And this is the structure with radiation pattern, and this is the axis of the antenna array. So the radiation pattern is perpendicular to the axis of the antenna array. And this is the design of the vertical collinear array of the antenna. Next design horizontal collinear array antenna. And this is the first design horizontal orientation of your dipole antenna, horizontal of your dipole antenna. So this is the design of the horizontal of your dipole antenna. And after designing half wave dipole antenna, select all the elements. Select all the elements. Right click on the elements. Go to edit, duplicate along the line. Click in the center position. Drag little bit. Select the number of elements. Now here I am selecting number of elements are 4. And the spacing between the elements is 62.5 mm. So now here the vector position is 0, 62.5, 0. Now click OK button. All the elements will be shifted to 62.5 mm. And second element is, and the spacing between elements is 62.5 mm, 0, 62.5, 0. And port elements. Now region boundary at 2.4 GHz operating frequency, and this is the design of horizontal orientation collinear array antenna. Now check the design validation, start the simulation. Simulation is successfully completed. Next observe S parameter value. Mark the designated operating frequency. So 2.4 GHz operating frequency, the return loss value is minus 22.70 decibel. Next observe the radiation pattern, 2D radiation pattern and 3D radiation pattern. And select the geometry is elevation angle. And now here the phi value is 0 degrees and 90 degrees. Select the gain without decibel and with decibel. First observe without decibel. And this is the radiation pattern. So now here all the elements are applied with currents with same magnitude and same phase shape. So now change the magnitude values. Go to the field overlays, edit the sources. So now here the magnitudes are 1, 0, 0, 0. All the elements are fed with same magnitude. So change the magnitudes. 1. Phase shift is same. Now click OK button. This is the radiation pattern, 2D radiation pattern. And this is the axis of the antenna array. The radiation pattern is perpendicular to the axis of the antenna array. Next observe gain radiation pattern with decibel. And this is the gain radiation pattern with decibel. Next observe 3D polar plot. So without decibel, the 3D polar plot is and its value is 4.45, and with decibel the gain value is 6.48 decibel, and this is with decibel, and this is the 3D polar plot without decibel. Next, observe the radiation pattern with the structure. And this is the radiation pattern with the structure, and this is the axis of the antenna array. So the radiation pattern of the horizontal orientation collinear array antenna is the radiation maximum radiation occurs perpendicular to the axis of the antenna array. And this is the axis of the antenna array. In that axis of antenna array, the radiation pattern is perpendicular.